The last type of reaction we're going to be talking about is an acid-base reaction. We also call these neutralization reactions, and you'll see why in just a second when we work with the word problem. In these, we have an acid and a base that react to form water and some sort of ionic compound or salt. So in this case, we have an acid right here. We have our chloride that is reacting with hydrogen. Remember, this is hydrochloric acid, so review your naming if you need to. Using our solubility chart, this is aqueous. So again, this is our acid. And our base, we have sodium hydroxide. So a lot of the examples you're going to see involve a hydroxide that reacts with a metal. So metals and hydroxides will give you this base. Again, use your solubility chart. This one is aqueous. And it is forming water and a salt. So how does that happen? So this is a double replacement reaction. So in this case, let's look at our sodium. We'll react with chloride. Here's our NaCl. But how did we get that water? Notice we had hydrogen on this first reactant, and we had hydroxide on the second reactant. When you have H plus and OH minus, you can get that to be water, H2O, 2 hydrogens and an oxygen. So this is a simple example of an acid-base or a neutralization reaction. Our next one, here's an example of a word problem. So we say phosphoric acid. Remember that ic ending, it was changed from ate. So we had phosphate. And again, use your polyatomic ion chart to remember that PO4 3- is phosphate. And of course, here's our hydrogen. And then we say that phosphoric acid neutralizes, that's where you get neutralization, a potassium hydroxide solution. So here's our potassium and hydroxide. And then we'll just crisscross those charges to figure out how many atoms of each. So H3PO4 is your phosphoric acid, and it is aqueous. Use the solubility chart. Plus potassium hydroxide, also aqueous. And they react to form water. So this hydrogen here with this hydroxide. And K3PO4. So here's your potassium, here's your phosphate. They will react together. And again, use your solubility chart to figure out the states of matter. And then notice that I added in a couple of coefficients here. This is to balance my chemical equation. So in this one, make sure that you are balancing your chemical equations. Our next example, we have hydrobromic acid that is neutralizing a calcium hydroxide solution. So hydrobromic, remember that hydro at the beginning and ic at the ending, it tells you that it is this bromide right here. So hydrobromic is HBr, and this is going to react with calcium hydroxide. So calcium has that 2+ charge, hydroxide. Remember to crisscross those charges. So hydrobromic acid and calcium hydroxide, and they will react to form water and calcium bromide. So again, check these solubility rules to figure out the states of matter. And again, I should have put my state of matter right here on calcium hydroxide. Let's go ahead and do that. So this was also aqueous by following the rules right here. So hydroxides are insoluble unless combined with one of these. So here's my calcium. So it makes it soluble or aqueous. And again, I added these 2 for the coefficients and 2 on this side to balance my